Okay, negative exponents. How can that be? What the heck is a negative exponent? So far, we've learned about the product property, which is like as long as they have the same bases, when you're multiplying two terms that have an exponent, you just add the exponents when they have the same base. Right? We've learned about the power of a product property that says if you have a base and then you have two exponents and you're multiplying those exponents, just multiply the exponents. That's fine. Right? We've learned about the quotient property that tells you that if you have the same base, just subtract. And we learned about the identity property, although we didn't talk about it a whole lot. We learned that anything raised to the first power is whatever that thing is. So cat to the first, it's just a cat, right? Let's look at this chart for a little while. All right, okay, this is telling us, I'm going to change to a black pen here, that 5 to the 5th, 5 times 5 times 5 times 5 times 5 is 3,125. Great. Well, if we divide it by 5, then we're going to have 5 to the 4th, because that's only 5 times 5 times 5 times 5, right? And that's 625. Okay, if we divide it by 5 again, we have 5 to the 3rd, 5 cubed, that's 125. 625 divided by 5 is 125. 125 divided by 5, which is now 5 squared, is 25. 25 divided by 5 is 5. 5 divided by 5 is 1. 5 to the 0 is 1, because you're dividing by 5 and you just keep going until you get 1, right? Anything to the 0, anything, is 1. Cat to the 0 isn't a cat anymore. It's 1. Dog to the 0 isn't a dog. It's 1. Anything to the 0 is 1. That's the 0 property of exponents. Okay, but let's extend this and just keep going. If we have 5 to the 0 is 1, what happens when we have 5 to the negative 1? Because now we're going to divide this 1 by 5. 1 divided by 5 is 1 over 5, because that's saying 1 divided by 5, right? Right? 1/5 divided by 5 is 1 over 25. 1 over 25 is 5 to the negative 2. Do you see a relationship here? Do you see a relationship between 5 to the negative 2 and 5 squared? So if we divide by 5 one more time, 5 to the negative 3 is 1 over, see, 25 divided by 5 is 125. Let's do it again. Divide by 5 again. 5 to the negative 4 is 1 over 3,000. No, I'm just kidding. 625, right? Do you see the pattern? Whatever number this is the same, but once you put that negative in front of it, the value becomes less than 1. 5 cubed is 125. 5 to the negative 3 is 1 over 125. It's smaller than 1. Much smaller than 1. In other words, 5 to the negative 2 is the same as 5 squared, but it goes under the fraction bar. It's smaller than 1. 1 over 25, right? And x to the negative 8 is the same as x to the 8th, but it's under a fraction. It is smaller than 1. It's less than 0. And if there's a positive exponent and a negative exponent, the positive exponent stays where it's at. If it's on top, it stays on top. If it's on the bottom, it stays on the bottom. The negative exponent is the one that moves. So a to the 5th, b to the negative 2, is going to be a to the 5th over b squared. It's like the fraction bar is a magic line. It erases negatives. This x to the negative 3 goes over the magic line, and it becomes 1 over x cubed. The negative sign no longer is there. It disappeared. Okay, let's try these. I see a negative exponent, so I'm going to draw a line. First thing, a to the negative 3. Well, since that's a negative exponent, it's going to go below the line, a cubed, and it loses the negative sign. B to the 6th. This is a positive exponent, so it's going to stay right where it's at. It's greater than 1. Anything less than 1 goes under, greater than 1 goes on top. Let's look at this one. I see a negative exponent, so I'm going to draw a line. X to the 5th. This is positive. It can stay up. Z to the 6th, that's positive. It stays up. F to the negative 2, well, that's negative. It goes over the magic negative erasing line. Ta-da! It's less than 1. Let's look at these two. I still see a negative exponent. So b to the negative 4th from the top is going to go to the bottom and lose the negative. F to the negative 3 from the bottom is going to go to the top and lose the negative. Does this make sense? Okay, what happens if you add a coefficient? Oh, I see a negative exponent, so I'm still going to start with drawing a line. And then I'm going to look at the numbers separate. I'm going to go 4 divided by 2. 4 divided by 2 is 2. Here's my negative exponent. This is on top, so it's going to go to the bottom. This is positive exponent. It's on top. It's going to stay where it's at. Here's a positive exponent. It's on the bottom. It's going to stay where it's at. This is a negative exponent. It's on the bottom. It needs to go to the top. You can't have negative exponents. It's not simplified if there are negative exponents. Now I can multiply x cubed times x squared. I'll leave the 2 up here, and I get x to the 5th, right? Because we just add them. Then I'm going to multiply y to the 4th times y to the 5th. I get y to the 9th. There we go. Ta-da! Let's do it again. Here I see some negative exponents. I'm going to draw a line. Let's look at the 16 and the 32 separate. Let's see, they both have a factor of 16, so I can divide both of those numbers by 16. 16 divided by 16 is 1. 32 divided by 16 is 2. Here's t to the positive 6. That's on top. It's going to stay on top. W to the negative 2. That's on top, but it's a negative exponent, so it needs to go to the bottom. And z, I can put a 1 on that if I want to. That's a positive exponent. It can stay right where it's at. Here's a t with a negative exponent on the bottom, so that has to go to the top. Here's a w with a negative exponent on the bottom. That has to go to the top. And a z with a negative exponent, that has to go to the top. Okay, now I can multiply these all together. 1 over 2, that doesn't change. T to the 6th times t to the 4th is t to the 10th. Oh, w to the 4th on top, w2 on the bottom. 4 minus 2 is w squared. And then z to the 1st and z to the 4th is z to the 5th. And there's our answer. Make sense? I always think that if you see negative exponents, draw the line, put everything where they belong, and then do the multiplication. Okay, so I see negative exponents, I'm going to draw the line. This 8 and 3, they have no factors in common, so they're just going to stay 8 and 3. X to the 4th, or negative 4, that's a negative, it has to go to the bottom. Y to the 6th, that's positive, it's going to stay at the top. Z to the negative, that's going to go to the bottom. Here we have x to the 4th, it's positive, it's on the bottom, it's going to stay on the bottom. It doesn't go anywhere if it has a positive exponent. y to the negative 3. Oh, that's a negative exponent, so it needs to go across the magic line, right? There's the line. Y cubed. Z to the negative 2. That has to go across the line too to get rid of that negative. Z squared. Okay, so let's do our multiplication. The 8 and the 3 stay. X to the 4th times x to the 4th is x to the 8th, right? Y to the 6th times y cubed is y to the 9th. And z squared divided by z squared, that's just 1. So there we go. See, it's pretty simple actually. Looks complicated, but it's not that bad. Just remember, the magic line erases the negative exponents.